Take a look at Module 2 Electrostatics, Homework B, Tab 2, the last part, and this is location of 0 of E fields of 2 charges, where we have to calculate the position of the x-axis where the total electric force, the total electric field is 0. Sorry. So first we have to understand the electric field contribution. So we have two charges, Q1 and Q2, where they are both positive, located at x1 and x2, respectively, with x1 being, I'm just repeating the question by the way, where x1 is less than x2. We're looking for the position x where the total electric field E subtotal is 0. The electric field is produced by a point charge Q at a distance r from the charge, which is given by, let's kind of write this in blue, where K is Coulomb's constant, Q is the charge, and R is the distance from the charge to the point in question. Because both of the charges are positive, the electrical field they produce will point away from each charge. The total electric field at any point will be the vector sum of the individual fields. So let's go ahead and set up the equation for the total electric field. We want to find the point where the total electric field due to both charges is 0. So let's consider a point x where x1 is less than x and x. I'm just going to go ahead and write this out. x1 is less than x, which is less than x2. So in between two charges. So the distance from charge q1 to the point x is going to be the absolute value of x minus x1. Oh, I don't know why that is not straight. That's as straight as me. X minus x1. And then the distance from charge q2 to the point x is going to be the absolute value of x minus x2, which is equal to x2 minus x. And the electric field at x due to charge q1 is going to be E1 is equal to k times q1 all divided by x minus x1 squared. The electric field at x due to charge q2 is going to be E2 is equal to k times q2 all divided by x2 minus x, and that's all squared. And because both of the fields point in the opposite directions, because q1 pushes the field to the right and q2 pushes the field to the left, the total electric field at x is going to be E1 minus E2, which is going to be k times q1 all over x minus x1 squared minus k times q2 all divided by x2 minus x and squared. So we want to find the point where the total electric field is 0. So we're going to go ahead and set k times q1 all divided by x minus x1 squared. And we're going to set that equal to k times q2 and then x all divided by x2 minus x and squared. So now we have to solve for x. So we're first going to go ahead and cancel k on both sides. So that's going to turn into q1 all divided by x minus x1 squared is equal to q2, that does not look like a q, q2, that does not look like a q either. And that's going to be x2 minus x squared. And now let's take the square root of both sides. So that's going to turn into square root of q1 all divided by x minus x1. It's going to be equal to square root of q2 and then x2 minus x. And now we can cross multiply and solve for x. So if we do the cross multiplication and solve for x, it's going to be the square root of q1. I'm actually going to rewrite this. Square root of q1 multiplied by x2 minus x is going to equal to the square root of q2 multiplied by x minus x1. And then we can expand both of the sides, and then that'll give us square root of q1 times by x2 minus square root of q1 times x is equal to the square root of q2 times by x minus the square root of q2 times x1. And we can rearrange the terms to group the x terms onto one side. So we can do square root of q1 times x2. I love my handwriting, it doesn't suck one bit. Plus square root of q2 times x1 is equal to square root of q1 times x plus square root of q2 times x. And we can factor x on the right hand side. So then that's going to turn into q1 times x2 does not look like a 2, plus square root of q2 times x1 is equal to x, and then in parentheses we're going to do square root of q1 plus the square root of q2. And finally, we can solve for x. So this will turn into x is equal to, on the top of the division sign, we're going to do square root of q1 times x2 plus then square root of q2 and then times by x1. And then it's all going to be divided by the square root of q1 plus the square root of q2. And that is going to be our final answer.